Hello, students. Our game Corefall has a lot of great systems working together right now. We have a player system that we can use for movement and getting input from our keyboard. We have our core gameplay system of our reactor cells that can undergo collisions and score goals. And we have a resource system that we can manage, our containment, that if we mismanage it, it means game over for us. There's only one glaring problem right now. Our game will run slow on slow computers. Our game will run faster on faster or high-powered computers. The reason why is because everything that we have written so far has been built on a frame-based system, or frames per second. So a slower computer might operate at a lower frames per second, and a faster computer could operate at a faster frames per second. And our game will be experienced differently on those two computers. That inconsistency is a big problem, and we end it here in this video. The way we do it is by moving our frame-based system to a time-based system, because 1 second is 1 second is 1 second of time, whether it's on a slow computer or a faster computer. And this will give us consistent gameplay across any machine that plays our game. We'll then leverage this new time-based system to create a difficulty ramp for ourselves so that our game increases in difficulty the longer and longer and longer it gets played. We'll do this by using a ramp system. So let's head over to the computer screen and dive right in. So I have lesson 5's starter file open right here in vscode.dev. I'm also going to minimize this for right now, and I'm going to open this file directly. So I'm going to come over here to my Corefall folder, lesson 5, and we'll open that directly in the browser so we can see what we have to work with. So if I hit enter to start the game, I can start moving. Whoa, I can zoom around the screen. Clearly something is wrong. Our movement system is busted, all right? So we're moving way too fast. All right, so we got to fix that. And if we look in our HUD, we've got some reference here to time, but it's not yet, moving forward. So this is clearly a broken state. I can't really. This is unplayable. I mean, this is really bad. So let's make it less bad. No, let's make it good. Let's make it really good. So we're going to come over to lesson 5.starter, and if we look at lesson 5, our delta time and difficulty ramp lesson, the first thing that we need to do in our mission checklist, mission number 1, is add the delta time variable and clamp it. So let's go see what this is all about. So I'm going to type in mission number 1 here in my search bar, hit the down arrow to go to the second instance of this tag, and mission number 1 exists in my draw function. So remember, the draw function gets called every single frame of the game. Our setup function, it's a P5, that library that we brought in, it's one of its default function, gets called once automatically at the start of the game. So when I refresh the game, boom, there it is. The draw function gets called automatically every single frame of the game. And see, this is the problem. Every single frame. So on a slower computer, those frames happen in longer intervals. And on a faster computer, they happen in shorter intervals. So what we're going to do is we're going to use a new value provided to us called delta time. Delta time is the number of milliseconds that has elapsed since the last frame has occurred. It gives us access to time, and that is exactly what we want. But we don't want time in milliseconds. We like to operate in seconds. So we're going to convert that time into seconds. The way we do that, milliseconds, seconds, there are 1,000 milliseconds in a second. So we can just divide by 1,000. And then we want to make sure that we prevent any like lags or giant spikes in gameplay. So we are going to clamp that value. So let's look at mission number 1. It says delta time setup. We're going to create the delta time or DT variable from our delta time value. We're going to convert it to milliseconds or convert milliseconds to seconds and then clamp it. So if you look right now, delta time is just set to 1. I don't think we want that. Like every time we run this, we're just saying 1 whole second has elapsed. I don't know about that. Let's change it to like 0.1. What happens if I change it to like 0.1? Well, I'm still zooming around the screen, but I'm not zooming around the screen as bad. What if I change it to 0.01? And I refresh the game. All right, I'm still zooming, but not as bad-ish. I guess maybe I'm still zooming as bad. Maybe that whole thing is broken. Regardless, we don't want it to be 0.1. We don't want it to be 0.01. We want it to be the amount of time that has elapsed since the previous frame. That is going to be in the variable delta time. But that's milliseconds, so I'm going to divide that by 1,000. Okay, so that's pretty good. But there's a problem here. What if our game lags or freezes and DT gets to become like some really big number? We don't necessarily want that. So we want to set some like maximum value. And so what we're going to do is we're going to call, we looked at constrain quite a bit already to set it between a lower and upper value, but we're going to call the minimum function here. And what the minimum function is going to do is it's going to just force the highest value for us. And so we're going to say, hey, whatever this value is, we're going to say grab the minimum of 0.033 and delta time divided by 1,000. So this is going to be like our default value if it spikes. So if this comes out to be like, I don't know, 2.2 seconds, we don't want our delta time interval to be 2.2 seconds if there's a huge lag. So we're going to take the minimum of 0.033 and 2.2 seconds, which is 0.033. So this is the largest value that our DT could be, which is going to prevent gameplay spikes, gameplay lags for us. So that's going to kind of just fix that. That's a little bit of nice work we can do to ensure consistent gameplay. So if I run this right now, our delta time variable is in effect, but I don't think we're using it anywhere because I still got this completely zoom in motion. My time interval's not going on here. So somehow we have to provide this time measurement to all of the functions that are going to need it. Well, let's look at what mission 2 is asking us to do. If our current game mode is play, is equal to play, we are going to update the runtime variable using our delta time using our new delta time. So you see we have this variable called runtime seconds. We're currently adding nothing to it. Where did we define runtime seconds? I want to just take a look. Let's go look at some of our constants and in our gameplay variables. What do we got to work with in this video? So here we got like max containment. Okay, so we got some ramp constants. Clearly this is going to be for a mission. We talked about this difficulty ramp that we're going to implement. So we'll come back to those. We got our player, our color palettes, and our gameplay variables. It looks like we've got runtime seconds. So if you look here, right, runtime seconds is probably this variable. It's reading 0 right now. And then we've got variables for our ramp, it looks like, which is, what did it say, mission 5? So right now, that variable runtime seconds, we are never changing it. So let's just add, I don't know, what if I just add like 1 to this? Instead of adding 0 every frame, what if I add 1 every frame? Hey, look at that. Time is zooming on by. Of course, that's definitely not correct. 300 seconds has not elapsed. 400 seconds has not elapsed. And the problem is because we are adding 1 single second every frame of the game. That is not at all good. So what we are going to do is we are going to add DT. DT is the time in milliseconds that we have converted from milliseconds into seconds that has elapsed since the last frame. So now when we run this, we should get an accurate representation of time. And look at that. We have time in our game, and we can use that time because right now, 7 seconds is 7 seconds on any computer, no matter how fast or how slow. And so what we're going to do is we're going to take DT. We just used it here to update runtime seconds, but we're also going to make sure that we pass DT into any function that is going to need to use time-based behavior. So I don't know. I honestly don't know what's going to need time-based behavior. Let's just go look through here. We got update ramp values, update player, check player cell collisions, and check cell goal collisions. Let's just kind of look ahead. Update ramp values. I don't think we need anything with time-based. Update player. It looks like the player is going to need to know about time because we have to move the player. And moving the player, we don't want to move them at a frame rate based on frame rates. We want to move them based on time. So update player needs DT. What else we got? Check player cell collisions. Looks like it needs DT. Why? Well, because we're moving the cells. And so we want to make sure we move them not based on frame rate, but based on time. So, all right, that looks good. And that's it. All right, so anything that needs moving needs access to this new delta time variable. So we're going to make sure that we pass those in. So update player, we're going to give it that DT variable that we just created. Check player cell collision, we are going to give it that DT variable. Ooh, not the XT, the DT variable that we just created. So now those functions have access to time. Mission number 2 is complete. Let's look at mission number 3. Mission number 3, we are going to use that delta time variable that we just passed into the update player function to properly move the player. How exactly are we gonna gonna maybe do this. So let's look at what we have here. We've got the player's X position is equal to the player's speed times the direction they're pointing in. So I think we've talked about these lines before. Remember, this is the size of their speed, and this is the direction of their speed, right? Either -1, +1, or 0. And same thing in the y direction. But there is a big problem here. And in order to maybe treat this, we're going to look at the whiteboard here in a second. Okay, so in physics, there's a pretty standard equation of motion in physics that says the average velocity or speed of an object, v bar, is equal to the distance traveled by that object divided by the time interval with which it was traveling. And so if you look here, this distance, we can think of that as like player dot x. Okay, that's its x position. So in our code, let's just go back to our code here. I have player.x, and then I'm setting it equal to this whole thing is the player's velocity, right? There's the size of their speed and their direction. So let me go back here. If I multiply both sides by time, so I multiply by t over here, those cancel. I got to multiply by t over here. And this tells me that distance is going to equal our velocity times our time. So this is the player.x. This is the player speed. And I'll assume both the size and direction, right? We've got both of those things, and dir for direction. But I'm missing multiplying by the time. So I got to somehow multiply by some value of time. Thankfully, we have it. It's dt. It's what was passed into our function. We passed it in. We gave update player access to dt. And so right now, we're missing that crucial element. We've got the speed right here, but we need to multiply by the time interval with which the object was moving, dt. I'm doing it in the x direction, and I'm going to do it in the y direction as well. Doing this, we should now hopefully, please, have fixed player movement consistent across all computers that is frame based. All right, so some of this is working. I think some of it's working. The player movement is working, but boy, is the cell movement not working. I'm like knocking the cells around all over the place. So you know what? I think we had to pass dt into the cells as well. I think the cells movement system is completely broken. And so let's see if we can look at mission number 4. Mission number 4, yeah, look here. It's the cell movement. So we passed in dt to the check player cell collisions. We have to use the exact same logic that distance is equal to velocity times time here to move the cell consistently across all frame rates. So here's our distance. Here's our velocity. What we're missing is the delta t. We're missing the times. Where is it? We're missing the times time. So let's put it in. All right, so don't do that. Player speed times dt. Player speed times dt. Doing this, now our cells should move wonderfully through a time-based system. Let's take a look. Hey, much better. All right, so we're moving those cells nicely. Awesome. Mission 1, done. Mission 2, Mission 3, Mission 4, done. Mission number 5. So our time system is in place, right? If we look at it, our time is being elapsed. It's showing in the HUD. Our players are moving with the new time-based system. Our cells are moving with the new time-based system. So I'm super happy. But now we're going to use that time-based system to create a difficulty ramp that we can use to scale the difficulty of our game. And it's going to be smooth and consistent in terms of how the difficulty increases. So let's head to mission number 5. We have to define or set our ramp constants. So if we look here, I've got 3 variables for my ramp. I have ramp time in seconds. I have cell spawn interval seconds start and cell spawn interval seconds end. So what are these numbers actually going to do for us? Well, right now, ramp time seconds is equal to 15. Think of this as how long it is going to take for the game to reach its maximum difficulty. Right now, the game is going to reach its maximum difficulty in 15 seconds. That seems a little bit too short. I'm going to set it to 75 seconds. So after 75 seconds of playing our game, we will be at our maximum difficulty. If you get to here, if you've survived for 75 seconds of your game, the game will no longer get harder. You just got to survive. How is it going to get harder? Well, if you look, we are going to change or decrease how long it takes for our cells to spawn into the game. Right now, nothing's spawning, right? We were manually doing, but eventually we're going to create a system that spawns a cell. When we start the game, it says start spawning a cell every 5.5 seconds. And a cell would spawn. And then we'd wait another 5.5 seconds. And a cell would spawn. By the end of the game, at its maximum difficulty, we're saying spawn them every 3.2 seconds. Those numbers just seem off for me. 5.5 seconds is a long time. So I'm going to start it at 2.5 seconds. Every 2.5 seconds will spawn. And by its maximum difficulty, I'll spawn a cell every 0.60 seconds. Now, how in the world do we control this? Well, it's through the aid of our ramp. And so I'm going to just draw a nice little graph because graphs are awesome. I love graphs. Imagine our ramp. Here is our ramp. Okay. So on the y-axis, we might have, let's just see. On our y-axis, we might have our values. So here's our starting value. So our starting spawn, start spawn. Let's make it my end spawn. No, how do I want to do this? Because our starting spawn, oh, I'm sorry. I got to just click and get over here. So let's see. We're going to make this. I can't erase with that anymore. Okay. I'll erase with this. All right, so let's think about this again. So our starting spawn is going to be really high. So our starting spawn is going to be up here. So this is our start spawn. Our starting spawn rate for our cells. And this is going to be our ending spawn rate. Ending spawn rate. And what did we set this at? Every 2.5 seconds. And this was 0.60 seconds. And on the x-axis, we're going to have some number that starts at 0 right here. And then goes to 1. When x is 0, we're going to be at our starting spawn rate. And by the time x gets all the way to 1, we will be at our ending spawn rate. And we're going to get a nice linear relationship. Boop. And so if we are at, say, like, I don't know, an x value, so these are our x values. If we're at an x value of, say, like 0.25, maybe an x value of 0.25 is going to put us right here on this ramp. So maybe the spawn rate is going to be about, I don't know, what would that be? Like 1.9 seconds. And if we're at, I don't know, let's say like 0.6 on the x value, maybe our spawn rate is going to be 1.1 seconds. All right, so we are going to be able to control this as this x value changes and goes from 0 all the way to 1. The ramp value will change, affecting our spawn. And this is known as a process called linear interpolation. Interpolation. This is called LERP, all right, linear interpolation. We're going to use LERP in our ramp to control the difficulty of our game. So let's take a look at how we implement this. So our ramp constants are set, okay, so I'm pretty happy with that. So now how do I define the ramp value, which is going to be from what? What did we say? From 0, right, from 0 to 1. Somehow we've got to set that number. That's going to be critical for us. So let's look at mission number 6. Our difficulty ramp. We are going to define the difficulty ramp value and normalize it or make sure it is always between 0 and 1. All right, so the way we're going to do this is when the game first starts, I want the ramp to be at 0. And when the game has reached its maximum difficulty, the ramp should be at 1. So when the game first starts over here, remember, runtime seconds, that variable we created. When we start our game, runtime seconds is equal to 0. And then when runtime seconds hits some magic number, I want it to be equal to 1, our ramp to be equal to 1. Do you know what magic number that's going to be? It's going to be, if we go back to mission number 5, our ramp constants. ramp time seconds. We said that, hey, this is the value that when we hit this amount of time, we should be at our maximum difficulty. And so we're going to compare runtime seconds to ramp time seconds. And when they are equal, we are at our maximum difficulty. Remember, our maximum difficulty is going to be given by the number 1 on our ramp. So this is going to be a nice ratio. We're going to define our ramp. And we're going to use the constrain. We're going to say ramp variable is equal to constrain. Oh my gosh, I have to spell it right. Constrain. All right, and we're going to take our variable runtime seconds, how long is the game played, divided by ramp time seconds. All right, that's the thing that we want to constrain. So when runtime seconds is 0, 0 divided by 75 is 0. Bloop. That puts us right here at the beginning of our ramp. And when runtime seconds is 75, ramp time seconds is 75, 75 divided by 75 is 1. Bloop. That puts us all the way over here at the end of the ramp at our maximum difficulty. But there's a problem. Runtime seconds is going to continue to go on and on and on. And so then it would be like 76 and 77, and then we'd get like 1.1, 1.2. We don't want that to happen because our ramp needs to be between 0 and 1. So what we're going to do is we're going to constrain it. We'll say the lowest possible value. We'll say the lowest possible value is 0, and the maximum possible value is 1. Where did we get this variable ramp from? You might be asking yourself that. You might say, hey, we're not declaring it. We're not using let or const. That's okay, because if we go up here to our gameplay variables, remember, under gameplay variables, we defined our ramp. All right, we said, hey, we're going to declare this variable as something that will change. Mission number 6 is now done. We've got this ramp. This value is going to be between 0 and 1. We just now need to use it to control our spawn interval. And this is where mission 7 comes into play. Linear interpolation, also known as lerp. We are going to use lerp to scale the cell spawn interval. We're going to adjust how frequently cells appear based on the difficulty. So if you remember, if I go back up to my gameplay variables, we used our ramp, but we also have a variable called cell spawn interval seconds. It's currently equal to 0 when we declare our gameplay. And when we reset our game values, let's just take a look at what it's set to. So here's reset game to defaults. Cell spawn interval seconds is set to our cell spawn interval seconds start. So it's set to 2.5 seconds. That corresponds to a ramp value of 0. Boop, right here at the start. Then what we need to do is we have to use our ramp to adjust this value, decreasing it and decreasing it, making our cells spawn faster and faster and faster, thus increasing the difficulty of the game. I can't believe I just said thus, but it sounded so good. I think I used it rightly. All right, so let's adjust that variable, cell spawn interval seconds. It's going to equal, we need to get its value through linear interpolation, also known as lerp. Lerp, we set our starting value. Our starting value for this is going to be the constant cell spawn interval seconds start. So it's going to be this second one right here. Tab to autocomplete it. Then we set our ending value. It's going to be cell spawn interval seconds end. It's going to be this first value right here. And then we set, so that fixes our endpoints, right? It fixes here and here. But then we have to give an x value that basically dictates where we are on this ramp between 0 and 1. Thankfully, I have that 0 to 1 value right here. It's my variable called ramp. And so we're going to pass in ramp. So that is going to change as runtime seconds changes as well. All right, I got to put a pesky little semicolon here. Where did that go? There we go. All right, let's check it. Let's run it. Guys, I got terrible news for you. I think the system is in place. I think the system is working, but we have no way to visually see it because right now we don't have a spawn system. We have built the runway for the spawn system. We know how to increase the spawn rate, but nowhere have we coded that these cells are going to actually spawn. Right? They only spawn when I score them. They just respawn automatically. I want them to randomly spawn throughout the game so we get more and more and more cells. We can get overrun with cells if we don't contain them. Bummer. We don't have that system in place yet. So what are we going to do? How do we know that our cell spawn interval is actually changing? Well, let's look at mission number 8. Mission number 8, it says we need to add a ramp display. We're going to display the ramp readout, show progression clearly in the HUD. So we're in our draw HUD function. We somehow want to show information about our ramp. Let's just see what we got to work with. If I scroll down a little bit, draw containment bar. Okay. Oh, here's a function. It's called draw ramp readout. We put some paint in our paint bucket. We align our text. We set the size. And then we get some ramp text, which shows the percentage the ramp is at. Okay, ramp times 100 times percent sign. We get our spawn text and our cell count. And then we create some text. So I think we want to just call this function. This is like a debugging function to help us make sure that our ramp is working properly. And we're going to call it right here when we draw our HUD. So I'm going to say draw ramp readout, two sets of parentheses, or a set of parentheses to actually call that function. Now, when we restart the game, we should see a ramp readout. And look at that. We got all that information right there. Before I start the game, the ramp is at 0%. The spawn interval, we said it starts at 2.5 seconds, and our active cells is 3. So let's just see. Right now, you can see as the ramp is increasing because our runtime seconds is increasing, the spawn interval is going down, it's going down, it's going down. I'm going to pause the video because I don't think you want to sit here listening to me talk until we are at our maximum time, which was, I think it was 75 seconds. So I'm going to pause this video for 1 second. All right, I'm just checking in with you. We're about 50 seconds in here, and our ramp is up to 67%. Our spawn interval is at 1.12 seconds. So our ramp is continually decreasing, right? We're moving further and further along as our ramp is getting from 0 to 1. All right, and then eventually when our ramp hits 1, I expect the spawn interval to be at 0.6, and that should happen at 75 seconds. All right, and 75 seconds, we're at 100, and there our spawn interval is set. So we have successfully implemented a delta time system. We have converted our game from frame-based to time-based, something that will run consistent on any computer. And then we use this new time-based system to build a difficulty ramp through the process of linear interpolation. So our difficulty will increase gradually and gradually and gradually. The way it increases is by actually decreasing the spawn interval, right? Our cells are going to start popping up faster and faster and faster and faster all over the battlefield, making it harder and more hectic, and therefore more fun for us to play. So we'll probably implement this pressure system of cells spawning automatically in our next video. So I can't wait to see you then.